In this video, we'll talk about properties of power series. So let's start with the radius of convergence. Now I want you to remember the ratio test was one of the tests that we used to check if a series converges. And we have, let sum as a sub k be an infinite series with positive terms, and let r equal limit as k is approaching infinity of a sub k plus 1 over a sub k. So I want you to also imagine that this can work for any terms if we put absolute value here. So if r is between 0 and 1, the series converges, including 0. If r is greater than 1, including infinity, the series diverges. And if r equals 1, the test is inconclusive. So let's try. Determine the convergence set of the given power series, sum as n equals 0 to infinity of 3 to the n over n factorial x to the n. So let's write limit based on the ratio test. Let's write limit as k it's approaching, n it's approaching infinity of absolute value of a sub n. Let's consider this whole thing our a sub n. So let's do a sub n plus 1, which means 3 to n plus 1 times x to n plus 1 over n plus 1 factorial, everything divided by a sub n, which is 3 to the n times x to the n over n factorial. So let's do some math here. Limit as n it's approaching infinity. 3 to the n plus 1, I'm going to write it 3 to the n times 3. X to n plus 1 is x to the n times x over n plus 1 factorial, it's n factorial times n plus 1. And then times, and I'm going to switch this fraction into n factorial over 3 to the n times x to the n. Absolute value. Now x to the n cancels with x to the n, 3 to the n with 3 to the n factorial with n factorial, and we end up with limit as n is approaching infinity of 3x over n plus 1. So as n is approaching infinity, it does not matter what it is, 3x, it's a finite value, divided by infinity is gonna equal 0, which is less than 1. So the series, or the power series, converges for any x values, which means the interval of convergence is negative infinity to infinity. Therefore, is it witty? The interval of convergence is negative infinity to infinity. Let's try another one. Determine the convergence set of the given power series. So this time, the power series is around, it's centered at negative 2. So we have limit as n it's approaching infinity, and let's skip some steps and let's put n plus 1 first, and then times and the reciprocal of a sub n. So we have n plus 1 squared times x plus 2 to the n times x plus 2, because it was 2n plus 1, over 2 to the n times 2, times, and now the reciprocal, 2 to the n over n squared times x plus 2 to the n. So x plus 2 to the n cancels with this one, 2 to the n with this one, and that's pretty much it. So we are left with the limit as n it's approaching infinity of a second degree at the numerator and a second degree at the denominator. So because the polynomial in n has the same degree, then we are going to end up with absolute value of x plus 2 over 2, right? The coefficients of n. Now, when is this power series convergent? When this quantity is less than 1. So that now we have to work on absolute value inequalities, which means absolute value of x plus 2 is less than 2, which means x plus 2 is less than 2, greater than negative 2, which means -4 less than x less than 0, or the interval of convergence is -4, 0. So if we choose an x value between -4 and 0, you're going to get the power series is going to converge. Now, when this happens, when we get something like this, we'll always have to discuss the endpoints to see, is it convergent at that point, or do I include the point, or I don't include the point. So let's check the endpoints. Always, very important, check endpoints. And, oh, point. So, if x equals -4, I go back into my series in here, or actually the whole thing, and see what we obtain. So the power series is sum as n equals 0 to infinity of n to the second over 2 to the n. If n is -4, we get -2 to the n. So basically, this one is sum as n equals 0 to infinity of -1 to the n times n squared. Now, -1 to the n times n squared, it's equal to n squared when n is even, and -n squared when n is odd. So I want you to think that you are adding n squared, so you get 1 squared plus 2 squared plus 3 squared. Obviously, this is diverging. And the same thing, if I put -n squared, we're going to get the same thing but with negatives. And these are negative. And these are diverging as well. So at -4 is divergent, so we'll keep the parentheses. Now let's check what happens at the other endpoint at x equals 0. So the series, the power series, becomes sum as n equals 0 to infinity of n squared over 2 to the n times 2 to the n, right? Just imagine that here instead of x, this time you put 0. So these two cancel and we end up with 1 squared plus 2 squared plus 3 squared plus ... which we actually know that S sub n, it's n times n plus 1 times 2n plus 1 over 6. So if you calculate limit as n is approaching infinity of S sub n of this quantity, you're going to get infinity. So this is divergent. So because of that, we are actually leaving our final answer in this format. So the convergence set is -4, 0. But you have to check the endpoints, because sometimes at the endpoints you might get convergent, so you have to include that. So the discussion needs to be discussed. Now let's take a look at this problem. Use the geometric series f of x equals sum as k equals 0 to infinity of x to the k equals 1 over 1 minus x. Remember the geometric series and how we were adding the terms. We had the formula. For absolute value of x less than 1, to find the power series representation for the following function centered at 0. So we have this function, and we have to come up with what is the actual series. So if we just compare this, we notice that it's one at the top, one here. One here, one here. Minus, minus. But this x is different. Here we have 3x. So how is that going to change? Well, here instead of x, we'll put 3x. So the actual power series is going to be sum as k equals 0 to infinity of 3x to the k. Or if you want, is 3x plus 3x to the second plus 3x to the third, and so on. Now, what is the interval of convergence? Well, if for the initial one it was absolute value of x is less than 1, in this case it's going to be absolute value of 3x is less than 1, which is actually absolute value of x less than 1/3, or the interval of convergence is -1/3 to 1/3. Okay, let's take a look at another example. Find the power series representations for g, which is this function, 1 over 1 minus x to the second, by differentiating or integrating the power series for f give the interval of convergence for the resulting series. So I want you to think of f of x, which is this one, and just above we have that it's actually sum as k goes from 0 to infinity of x to the k. This is the meaning, this is the series that equals 1 over 1 minus x. Now think about the connection between f of x and g of x. I would say if we differentiate f of x, which is 1 over 1 minus x prime, we are going to get exactly 1 over 1 minus x squared. So in other words, if we, in order for us to find g of x, we should differentiate f of x. So we are going to differentiate with respect to x the series sum of k equals 0 to infinity of x to the k, and the differentiation is done pointwise. So in we can think like this series is 1 plus x squared plus x cubed plus dot dot dot, which if we differentiate every point we get 1 plus 2x plus 3x squared plus dot dot dot, which we can write as sum as k equals 1 to infinity of k x to k minus 1, which is exactly differentiating this piece directly. So in other words, again, how do we find the power, what is the power series for g of x? The power series for g of x, it's exactly this sum here, sum as k equals 1 to infinity of k x to k minus 1. So now just a quick discussion about the interval. So if we calculate limit as k is approaching infinity of a sub k plus 1 over a sub k, so again this is our a sub k, and a sub k plus 1 it's here, and a sub k it's here, and if we compute that, we end up with absolute value of x, and in order to converge we have to compare it with 1, which is going to generate negative 1, 1. But we need to check the endpoints. So if x equals negative 1 in this power series, we end up with sum as k equals 1 to infinity of k times negative 1 to k minus 1. And if we give values, we end up with 1 minus 2 plus 3 minus 4 plus 5 minus 6. And if we think about it, that's actually negative 1 plus negative 1 plus negative 1, which is going to give us negative infinity. So at negative 1 it diverges, so we leave parentheses. At x equals 1, if we plug in x equals 1 here, we're going to get sum as k equals 1 to infinity, which is k of k, and it's 1 plus 2 plus 3 and so on. Now the sum, the nth partial sum s sub n is 1 plus 2 plus 3 and so on, which is, or plus n, which is n times n plus 1 over 2. And if we calculate the limit, we actually get infinity, which means it diverges at 1 as well. So the final interval of convergence for our problem is negative 1, 1. And a couple more problems. Write the following power series in summation notation. So let's do sum as k equals 1 to infinity. We have 1 plus x over 2 plus x squared over 4. So how about we put x over, well, it's 2 times, so x to the n times 2 over 2 times n. Let's see. If n equals 1, we get x over 2. If x equals 2, we get x squared over 4, and so on. But we are not getting the first number. So what should we do? We just add a 1. Okay, the next one equals, we have an alternating series because we have minus, plus, minus, plus. So we have sum as k equals 1 to infinity of negative 1 to k, x to 2k over k factorial.